This is R.D. Sharma Solution Class 12, Chapter 19. Exercise is 19.28 from Indefinite Integrals. So there are three very important formulas or result. Integration of a square minus x square dx. So this is equal to x by 2 under root a square minus x square plus a square divided by 2 sin inverse x by a plus constant of integration. Now the second formula, you can write it as x square plus a square or also a square plus x square, they both are same. And the result is x by 2 under root x square plus a square by 2 log, and inside the bracket we have x plus under root x square plus a square plus a constant of integration. Now this is very important, under root x square minus a square, and the result is x by 2 under root x square minus a square by 2 log x plus under root x square minus a square plus constant of integration. Now these three are very important, and how they are going to be proved I'll show you in just a bit. Under root a square minus x square, this integral, and the direct result after integrating this is x by 2 under root a square minus a square plus a square by 2 sin inverse x by a plus c. Now the result is okay, but how actually we have got to this result? That is, integration of u dot v, u is the first function, v is the second function. So the result will be u integration of v, that is the integration of v with respect to dx, minus integration of differentiation d by dx of the first function, which is u, and the integration of the second function. Now when you multiply these two, then the result will be dx, that is one more time we'll be integrating it. So we have this under root a square minus x square. So integration of a square minus x square, how are we going to go about it? What are going to be the steps? So you know already that root x is equal to x to the power half, x raised half. So we'll do it by the integration by parts. So we'll assume that 1 is already there. We don't have to assume because 1 is already multiplied by every number. Now we'll take the first function as under root a square minus x square and second function as 1, as I indicated you in integration of u dot v, the formula we are going to use just now. So the first is under root a square minus x square, integration of 1 dx minus integration of now the differentiation of the first function, which is under root a square minus x square, then the integration of 1 dx, and then final multiplication of these two, differentiation and integration, and again the integration. So what do we get? 1 dot dx is x only, integration of 1 is x, and under root a square minus x square is untouched. Now this d by dx of under root a square minus x square that we are going to do. Now under root x differentiation is 1 by twice under root x, you already know that. So we can just write it as, after differentiation, 1 by twice of under root, what is there? A square minus x square. But we need to differentiate a square minus x square also. So when we differentiate a square minus x square, a square is a constant, it will go 0, and negative x square will give you negative 2x. So you can write negative 2x here. How about integration of 1 dx? This will be x only. So let's write x here. Now this x into x, I can just write x square here. It can be written in the next step, but you understood now. So it is x square, x into x. Now we need to integrate this second part. First part is already done. So this 2 will get cancelled, but will not do anything with this negative sign. So negative x square divided by under root a square minus x square, I am explaining it separately. Now you know this a square minus x square is in the denominator, you need a square also in the a square minus x square in the numerator. For that, add a square and subtract a square, and then separate these two terms. A square minus x square is the first term, and second term is negative a square. So x square minus x square divided by under root a square minus x square will take as the first term, and then minus integration of a square divided by under root a square minus x square will be taken as the second term. So this minus, sometimes you are tempted to just take it outside and make it as positive. But here, this is not the case. You need to keep this negative in order to make it a square minus x square like that. Now we need to replace it here, because actually the second part I told you, and there is a negative multiplied. So I'll just multiply negative and then replace it. So when you multiply this negative, the sign will get changed. So we have x under root a square minus x square as the first one, which is already unchanged. And then we have this whole, which I explained you separately. This you can place it here. But before going that, we can simplify it more. Because a square minus x square to the power 1 divided by under root a square minus x square. Under root a square minus x square is a square minus x square to the power half. You already know that. So this base is same. So this half will go up. So it will be like x to the power 1 into x to the power negative half. So it will be x to the power half like that. So it will be under root x. And what is x? Under root, this is a square minus x square. So you'll get a square minus x square and to the power half, and this half is nothing but under root, which I told you in the beginning. So under root a square minus x square can be written in this place. Alright? So you have minus, and then you can write this. There is an integration also, right? A square minus x square under root a square minus x square. Let me write it like this. Then we have this a square by under root a square minus x square. So a square you can take common. So plus a square you just take outside. And after this integration you have 1 divided by under root a square minus x square. Now we have a direct result. See, there are two things which need explanation here. First is under root a square minus x square is the actual term from where we started. It is I only. From here only we started. So you can just replace under root a square minus x square integral as just I. So just write x under root a square minus x square. In this place you just write I, and I is on the left side also, and plus a square. Now this one I was telling you that 1 by under root a square minus x square is nothing but sine inverse x by a. It's just sine inverse x by a. You just write sine inverse x by a here. Sine inverse x by a. Okay, this negative I can be taken on the left. So I minus I, that is actually I minus I, when you take negative on the left hand side, it is I plus I. So it will be twice I. So 2i will be equal to, now I have already taken this out. So x under root a square minus x square plus a square sine inverse x by a. Now we have a 2 on the left hand side. So just take these 2 downstairs on the right hand side. So we have x by 2 under root a square minus x square plus a square by 2 sine inverse x by a, which is the second term of the result which I showed you earlier, plus a constant of integration. So this is your final result and proof of this expression or result. Now this under root x square plus a square dx is equal to x by 2 under root x square plus a square by 2. Then we have a log x plus under root x square plus a square plus a constant of integration. Now from where this formula has come, or from where this result has come, we need to prove it. We need to show the examiner or the person that okay, this is how it has come. So let's solve it first and give you the proof. So we have this I, we are calling it as I, and this is equal to under root x square plus a square integration. Now you can write it as a square plus x square and x square plus a square interchangeably because they both are same. So we'll do it by parts. That is, we assume that is 1 is multiplied here and dx is already there because we are integrating. What is the first function? The first function will take it as under root a square plus x square, and second function will take it as 1. Now when you have two functions and you want to integrate this, we apply a certain formula, or as a result u integration of v dx minus integration of differentiation of first function, integration of again the second function, and that differential and integral will be multiplied and then it will be integrated again. So this will come outside because this is the first function, a square plus x square. Then we have the integral of what? 1 dx. Then minus integration. Then the differentiation of the first function, which is under root a square plus x square. Then after this, integration of 1 dx again. That is the one which we are doing for the parts, and we assume that 1 is multiplied there. And then again the integration. So this 1 dx will simply give you x. Under root a square plus x square is here. It remains unchanged. Minus. Now integration of what? 1 dx is going to be x only. Let's call it x here only, because I am going to replace it. Now d by dx of under root a square plus x square can be done separately, because you know d by dx of under root x is 1 by twice under root x. So if you assume this under root a square plus x square as under root x, it will be simply 1 by twice of under root x. So under root a square plus x square I have written. Now you don't have to stop here. You have to differentiate a square plus x square also. Now what is the differentiation of a square plus x square? A square will be 0 and x square will be 2x. 2 you can cancel now. So this will give you, I am not writing x right now, just writing the denominator a square plus x square under root. Now why I am not writing x? Because integration of 1 dx already gave us x. We got a x from here also. X into x will be x square. That can be written. And then the integration with respect to dx. First part is already done. Now we need to concentrate on the second part, which is x square by under root a square plus x square. So x square is here in the numerator. A square plus x square is in the denominator with under root. Alright. Now I need this a square plus x square upstairs. So just add a square and subtract a square. When you add and subtract a square, what are you going to get? A square plus x square, you can separate it out. But remember, there is an under root in the denominator. So a square plus x square by under root a square plus x square. This is under root and this is also under root. Then minus a square divided by under root a square plus x square. We have separated these two terms and we will integrate them separately in a different way. Means in a different terms. So you know that x divided by under root x, it can be written as what? X to the power 1 by x to the power half. It goes upstairs. X and x 1 and minus half will give you half only. So x to the power half, that is under root x only. So you'll get under root x in this case. So you can just write under root a square plus x square and integral of this one. Now if you take a square outside, only 1 by under root a square plus x square will be in the denominator, that you already know. So this whole is like this. Okay. Now before we go ahead, this negative, let's multiply this in the separate terms which I showed you. I am making it negative and this is as positive. So we have dealt anything which is outside this x under root a square plus x square, which is coming after that. Okay. So we have this negative under root a square plus x square integration first, and then the second term is plus a square we have already taken out, and integration of 1 by under root a square plus x square or x square plus a square, you can write any of these. Now what do you see here? This under root a square plus x square integral is what we have started. This is I only. And what about this one, a square? Let's write the first term first, then I'll tell you about the last one. X under root a square plus x square is already there. Minus I will take on the left hand side. A square is outside. 1 by under root a square plus x square has a direct result. Now let me write it here. And I am writing it here just to keep this thing inside your mind. Like it is log modulus of x plus under root x square plus a square. So in place of integration 1 by under root a square plus x square, just write this log x plus under root x square plus a square. So let me write it here. Log modulus x plus under root x square plus a square or a square plus x square, and better is to keep it inside the bracket after log actually. Now this negative I goes on the left, I minus I, that is I plus I will become. So I plus I will become what? Twice I. Just write 2i here. On the right it will be x under root a square plus x square, and the second term is what? See, just try to coincide with that actual result. So a square log and bracket I am changing now, x plus under root a square plus x square as the second term. Now these two I am bringing downstairs on the right hand side. Now you see this is the result. How easy it was? Under root x square minus a square dx. This is equal to x by 2 under root x square minus a square by 2 log modulus inside this bracket x plus under root x square minus a square. Now what is the proof? How did we get or arrive at this result? Now we are going to prove it for you. So before we go ahead, there are certain things. Integration of u dot v, that is u is the first function, v is the second function. When you integrate this, what is the result? The first function will take as it is. If you assume u and v are the first and second function respectively, u integration of v dx minus integration or differentiation of the first function, which is d by dx of u, and then the integration of v dx. When all of this is done, this will be integrated again. Okay. So this I will be equal to integration of under root x square minus a square. Now the problem is how we are going to go about it. We'll do it by parts. That is, we'll assume that it is multiplied by 1. We don't have to assume, it is already there. 1 is multiplied by every term. And then what is the first function and the second function? So let's take I as the first function as u and the second function as v. So I'm applying this formula now. Under root x square minus a square. Then we have integration of 1 dx minus integration of d by dx of what? Under root x square minus a square, and then integration of 1 into dx, and then after this we will have the final integration. So what are we going to get here? 1 into dx will give you x, and then x square minus a square is unchanged. D by dx of under root a square, x square minus a square, I'll just tell you now. 1 dx will give you x, so let me write it here. I'll just combine it with d by dx of under root x square minus a square. So remember, this is 1 dx is x. Now this is very important. So I'll just do it in a side d by dx of under root x is 1 by twice under root x. When you differentiate d by dx under root x square minus a square, it is going to give you 1 by twice of under root x square minus a square. That is very well known to you because you have done already the differentiation part. So d by dx of under root x square minus a square, as I told you, d by dx of under root x is 1 by twice under root x. So d by dx of under root x square minus a square is 1 by twice under root x square minus a square. And then we have to differentiate x square minus a square. That will give you 2x. So now this is 2x divided by 2 under root x square minus a square. I am cancelling 2. So you have x by under root x square minus a square as the differentiation. So I am not writing x upstairs. I am just writing under root x square minus a square because x is what we got from here, but x was earlier integration 1 dx, if you remember. I told you. So this x and x combined multiplied will give you x square dx. Now I am going to show you this integration of the second part separately. So it's x square by under root x square minus a square. We need x square minus a square upstairs. For that you have to add negative a square, subtract negative a square. So just subtract a square and then you have to add also because you are doing it by yourself. Now separate these two terms out. X square minus a square divided by under root x square minus a square will be the first term because we are separating these two terms. And then we have a square divided by under root x square minus a square. I am taking a square outside the integral sign. So 1 by under root x square minus a square remains inside. So this simply can be explained by x by under root x. This will give you what? It will give you under root x only because it is x to the power half, x to the power half in the denominator. It goes up. It will be negative half. 1 minus half is half only, and anything to the power half is just root. It's just root x. So just making similarity or analogy, it's simply under root x, which is under root x square minus a square in this case. So x square minus a square comes here. Now a square comes outside. 1 by under root x square minus a square is already lying there. Okay. Now negative is already there. So multiply negative here. So both the terms is going to get negative. So we have dealt anything which is coming outside or after x under root x square minus a square. So let's write x square under root x square minus a square. Then you have negative under root x square minus a square. Then you have minus a square outside 1 by under root x square minus a square already then. Now you see there is already an I in between. This is I only. Okay, from where we started, this is I only. So we can just replace the middle term by I, and this one x under root x square minus a square remains unchanged, and this is negative a square, but there is a direct result for integration of 1 by square root of x square minus a square. What is the result? I am writing the direct formula. It's log modulus of x plus under root x square minus a square. Now let me write it again because my writing is very good as you see here. So log modulus x plus under root x square minus a square. This is the result. Now this negative I can be taken on the left. It will give you I plus I. And I plus I is going to give you twice I. An I for an I. Who told me this line? Tell me. Okay, now this is 2I. I'm not writing 2 because I'm going to take it downstairs. So let me write other things. X under root x square minus a square. I is already done. Minus a square log modulus of x plus under root x square minus a square inside the modulus. Don't forget to write the modulus. Now this already had a 2. So I'm bringing it downstairs on the right. So it's 2 in the denominator plus a constant multiplication. From here to here, that's your final result. Under root 3 plus 2x minus x square. First we have to make it as a perfect square and then we'll use the formula. What is the formula? Let me tell you the formula first. So under root a square minus x square is equal to, when you integrate this, the proof also is being told to you or explained to you earlier. So it is x by 2 under root a square minus x square plus a square by 2, then sine inverse x by a plus a constant of integration. Now we need to make it as a square minus x square so that we can apply this formula. How are we going to do that? So take this first, 3 plus 2x minus x square. In order to make the perfect square, we don't need anything in front of x square. We don't even need a negative. So that's why I am taking a 3 minus whatever is inside. I just made it as negative so that the 2x minus x square become of different sign. So whenever you take ax square plus bx plus c kind of quadratic equation, in order to make it as a perfect square, you want a to be not there, to be removed, and x square should not have anything in front of it. So we have 3 minus x square minus 2x, but in order to make a perfect square, whichever is any constant or anything which is prior to x, you just divide it by 2. 2 by 2 is 1. You square it. Whatever comes, you add and subtract. That is x square minus 2x is there. Add 1 and subtract 1. So this is a square plus b square minus 2ab. That means it's x minus 1 whole square. What is remaining? Minus 1, negative 1. But remember, it is preceded by 3 minus. So just open it up. And when you open it up, it will be 3 minus x minus 1 whole square plus 1. Minus minus will be plus. So 4 minus x minus 1 whole square has come. But fortunately, this 4 can be written as 2 square. So it will be 2 square. Say if it would have been 5. You cannot have a perfect square. For that, you just put a root and then square it. So you have 2 square minus x minus 1 whole square. So a square minus x square under root. So we will take a as 2 in this case and x as x minus 1 and just use this formula which I intimated you earlier. What is x here? It's x minus 1. In place of x, put x minus 1. So it will be x minus 1 divided by 2 under root. Now this a square minus x square, which is actually 3 plus 2x minus x square. We started with this term only, or this quadratic equation only, and then we made it as a perfect square. So you can just write a square minus x square as 3 plus 2x minus x square. Then an addition sign. A is what here? 2. So 2 square by 2, that will give you 2. So sine inverse x by a will remain like that. But what is x here? X minus 1. A is 2. And there is a 2 also in front of it, which we have got from 2 square by 2. That is a square by 2. And that is your final result. Just add a constant of integration also. So this is your final result. Now how to do this? The whole process is put in front of you now. You can try this. X square plus x plus 1. So we have to make this as a perfect square. Whenever we encounter an under root, then we need something square inside under root so that we can either get things out of under root or solve it using certain formulas. So x square plus x plus 1, we have the coefficient of x as 1. So whatever is the coefficient of x, when x square has nothing in front of it, you divide it by 2. So 1 divided by 2 is 1 by 2. Then you square it. It will form 1 by 4. Add 1 by 4 and subtract 1 by 4. Let me write 1 by 2 whole square only in this case because I am going to make it as a perfect square. So a square plus b square plus 2ab, x square plus half square plus 1x is x plus half whole square. And what is remaining? 1 minus 1 by 2 whole square. That is 1 minus 1 by 4. So this will give you 3 by 4. Now in order to make it as a perfect square, since we have an odd number and also cannot be made as a perfect square, make it as root 3 whole square. 4 already has 2 square. So this becomes root 3 by 2 whole square. This root 3 by 2 whole square can be written like this here. Now x square plus a square formula, which we can see here. So this is all under root. I just explained you without under root so that you can solve it and then take care of the under root. So this x square plus a square formula, as you are quite aware, it is x by 2 under root x square plus a square by 2 and log base e, you can write it as ln also, and in this you have x plus under root x square plus a square, then you end it in a constant of integration. What is x here? X we will take as x plus half, x plus 1 by 2. See why this x can be taken as x plus half? Because when you differentiate x and when you differentiate x plus half, it's going to be same. It will give you result as 1. That is why we can take x and x as x plus half. Because most of you will ask question that the formula is of under root x square plus a square. but you are taking x as x plus half, which is not fair. But here, since the differentiation of both the term x and x plus half are same, we can take x as x plus 1 by 2 and a will be taken as root 3 by 2. Now I'm putting all this in the formula. X plus half, which is x, divided by 2 under root. Now here x square plus a square, this has come from where? From this only, x square plus x plus 1. So you can just write x square plus x plus 1 in this case. Then we have plus a square by 2. A is root 3 by 2. So root 3 by 2 whole square was 3 by 4 only. Earlier you have seen. And this has a 2 also in the denominator. So it will get multiplied by 2, 4 will be. So this will be 3 by 8. Then take the log, then the modulus, x plus half whole square because x is x plus half. And again under root x square plus a square, don't have to worry about anything, just write x square plus x plus 1 in this place. And plus a constant of integration. You can also resolve it more because writing x plus half is not seen that much simplified. So you can write it as 2x plus 1 by 2. 2 is already there in the denominator. So it will form 4. Inside this you have under root x square plus x plus 1 plus 3 by 8. Then you have a log. Modulus of x plus half is 2x plus 1 by 2. So it will be 2x plus 1 divided by 2. And the rest term, the other term will be the question only, which is under root x square plus x plus 1. Ended with a constant of integration, and that's your final result. Now this is how you are going to perform or write whenever you are writing, and do keep in mind all the other things which I told you. Under root x minus x square dx. Now the previous two question has laid down the foundation of this question only. How? Because you already know you have to make it as a perfect square. Then you have to apply certain formula. X minus x square, that means there is a negative in front of x square, so we need to get rid of it. First thing. So if you take negative outside, this will be x square minus x. And this is a proper quadratic equation. When you have a quadratic equation like this, whatever is in front of x, which is 1, the coefficient, you divide it by 2. Then you square it. So 1 by 2 square you will use, and that will be added and subtracted. So minus is already outside. X square minus x is already there. We are adding half square and subtracting half square in order to make it as a perfect square. So a square plus b square minus 2ab, it will be x minus half whole square. Then you have negative half whole square. So minus is already in front of that. So we need to get rid of this negative. So you can just swap these two terms, or you can change the sign of the inside two terms. So the final integration will be like this. It will be half whole square first, followed by minus x minus half whole square. So let me write it half whole square minus x minus half whole square, and this is inside a root. So a square minus x square under root is what we are going to solve here. But we need a formula, and we have a formula. Under root a square minus x square is equal to x by 2 under root a square minus x square plus a square by 2 sine inverse x by a plus a constant of integration. Now if you match this, a will be half and x will be x minus half. So just use this formula and use this a and x wherever it comes. So we have x minus half by 2 under root. Now this a square minus x square is essentially the same integral from where we started. So it is only x minus x square plus a square by 2. What is a? Half whole square. What is 2 divided by 2? So it will be 1 by 4 and 2. So 4 into 2 is 1 by 8. Sine inverse x minus half divided by half. So x minus half divided by half, we cannot keep it like this. We will resolve it in just a bit. What is x minus half? It can be written as 2x minus 1 divided by 2. 2 is already there in the denominator. So it will be 2x minus 1 divided by 4. So 2x minus 1 divided by 4 has come. Under root x minus x square is there. Plus 1 by 8 is there. Again this is 2x minus 1 divided by 2. You have a half in the denominator also. 2 gets cancelled. You have sine inverse 2x minus 1 plus constant of integration. This is your final result. And this is how you need to solve it. Okay. The formula is very important. If you remember this, it will be good. So this question is 1 plus x minus 2x square. There is a negative 2 in front of x square, so we need to get rid of this negative 2 in order to make it as a perfect square, because we need a perfect square inside so that we can apply certain formula here, matching it. So I'm just taking negative 2 outside. So whenever you take something outside, it's just like dividing everything by negative 2. So divide everything by negative 2 and just write the result. First will be negative half, second will be negative x by 2, third will be negative 2 cancelled, and you just get an x square. And that is what we wanted. We don't need anything in front of x square. We just need it as positive also. So this I am rewriting x square minus x by 2 minus half. So this is also a quadratic equation. Now this quadratic equation has the coefficient of x as half. It's actually negative half, but we don't worry about negative and positive in this case. So whatever is in front of x, which is negative half, just remove the sign and take the number. 1 by 2 is there. So divided by 2, 1 by 4 will come, square it, 1 by 4 whole square. That has to be added and subtracted. So negative 2, when you take it out, it will be x square minus x by 2. You add a 1 by 4 whole square. Then you subtract a 1 by 4 whole square. And then we have a negative half also. So a square plus b square minus 2ab. So x minus 1 by 4 whole square. And this is negative 1 by 4 whole square minus half. You can take just negative common. 1 by 4, 4 is 16. Plus 1 by 2 will be there. So you can take the LCM and solve it. The better way is to take half outside first. 1 by 8 plus 1 will remain. And this will give you 1 into 1 plus 8 into 1 divided by 8 into 1. This will give you 9 by 8 into 2, 9 by 16. Negative 9 by 16 has come. So minus 9 by 16, but in place of 9 by 16 you can write 3 by 4 whole square. So this will be 3 by 4 whole square, but there is a negative 2 also outside. So first we need to get rid of this negative. So we will swap these two terms, or you can say we can change this sign of these two terms. So this will be 3 by 4 whole square minus x minus 1 by 4 whole square, as we multiplied negative inside, and there is a root 2 also remaining. So that root 2 will be multiplied later. Root 2 will be multiplied later. So we need to deal with under root 3 by 4 whole square minus x minus 1 by 4 whole square first. For that we need certain formula. So a square minus x square under root is given by x by 2 under root of a squared minus x squared plus a square by 2 sine inverse x by a plus a constant of integration. A you are going to take as 3 by 4 and x you are going to take it as x minus 1 by 4. So x minus half 1 by 4 divided by 2 under root. Now this a square minus x square, when it is multiplied by under root 2, it will come as 1 plus x minus 2x square. See, I told you under root 2 is already there. When you multiply this 2 inside, it will give you under root a square minus x square. That's why I have written this. Now a square by 2, that is root 3 by 4 whole square divided by 2. So 3 by 4, it will be 9 by 16 divided by 2, it will give you 9 by 32. And you have sine inverse x by a. X is x minus 1 by 4. A is 3 by 4. So x minus 1 by 4 divided by 3 by 4. Now let me do it somewhere else. So x minus 1 by 4 is simply 4x minus 1 by 4 divided by 2. So this will give you 4x minus 1 divided by 4 to the 8. So the first term will have 4x minus 1 divided by 8. And when you multiply this under root 2 inside, this will only come, the original equation will come. If you multiply this x minus 1 by 4 whole square minus 3 by 4 whole square with under root 2, same result is going to come. That is why I am saying root 2 is multiplied to the first term, it will directly give you the original equation from where we started, or original question from where we started. So I am writing it as 1 plus x minus 2x square, the original thing from where we started. And this will only come when you multiply it by under root 2, and under root 2 is already outside. So under root 1 plus x minus 2x square has come. The next will be 9 by 32, and there is a under root 2 also, because you need to multiply it with both the terms. So you have 9 by 32 into root 2. Sine inverse x minus 1 by 4 is 4x minus 1 divided by 4, and 3 by 4, so 4 get cancelled, only 3 will remain plus a constant of integration. This is your final answer, which you are going to follow. Remember this formula, it will be easier for you to solve this question. Cos x under root 4 minus sin square x. So by the virtue of differentiation, we know that sin x, if differentiated, can give you cos x. And since we are doing the exercise or the questions of certain formula, that formula can be applied. So if we take t equals to sin x, or assume t equals to sin x, and we differentiate both the sides, dt by dx will be equal to d by dx of sin x, that will give you cos x. So dt will be equal to cos x into dx. And what do you see in the question? Cos x dx is already there, and we can replace wherever sin x is there by t. So what are we going to get after this substitution or assumption? In place of cos x dx, I am writing dt, and inside the root, 4 can be written as 2 square and sin square x can be written as t square. And you already know and you are aware of this formula or this result. Under root a square minus x square is given by x by 2 under root of a square minus x square. Then we have plus a square by 2 sine inverse x by a, plus a constant of integration. A we are going to take as 2 and x as t, because we assume t. We are going to replace it in near future, but right now we will use these to put in the formula. Let's go ahead and put t by 2. A square minus x square will be 4 minus t square. A square by 2, a is 2 square, 2 square by 2 is 2 only. Sine inverse x was t and a is 2. So t by 2 we get. And then we have t equals to sin x. So replace wherever you get t as sin x. So this will be sin x divided by 2 under root of 4 minus, what is t? Sin x originally. 4 minus sin square x plus 2 sin inverse t by 2. What is t? Again sin x. Sin x divided by 2. Just add a constant of integration. T equals sin x, we replaced it, and after this replacement we get this expression, which is the final result. Now how we are going to go about it or write it is in front of you. This is for those who want reference. In the same way, we can see that e raise x will always give you e raise x. So if we take e raise x as t and differentiate both the sides, e raise x will be e raise x and t differentiation will be dt by dx. So you can write e raise x as dt by dx, and then you can get a dt by multiplying this dx on the left side. So dt will be equal to e raise x dx. So these both are known to us now, or we are ready for the replacement. E raise dx I am replacing by dt. Inside the root, since e raise x is only t, but e raise 2x will be what? If you make t square, it will be e raise 2x. So e raise 2x can be written as t square, and for 1 I just swapped these two terms and made it as a square. So this integration will be like this, because t of course is now what we have assumed. So it will be t square plus 1 square. You can write it as 1 square plus t square also. Now we know the formula, we are aware of the formula of a square plus x square, or x square plus a square under root integration. It is x by 2 multiplied by under root a square plus x square plus half ln x plus under root ln is log base e. X plus under root x square plus a square, there is a slight mistake which I am going to just fix. But right now it's just x plus under root x square plus a square. Take x as t, a as 1 and replace it here. So t by 2 under root 1 square plus t square plus half ln is log base e modulus t plus under root x square plus a square. As I told you, I am going to fix it just now. It's just x plus under root x square plus a square only. So t plus under root t square plus a square, which is 1 square. Now if you remember, t was e raise x we assumed earlier. So now replacing t by e raise x, it will be e raise x by 2 under root e raise 2x plus 1 plus half ln log base e modulus e raised x plus under root same content e raised to x plus 1 and plus a constant of integration. This is your final result. And for the reference, I'm showing it to you. You can solve it by using, and one more important thing is the formula. Under root 9 minus x square. Now this is a straightforward formula only. We have to apply the formula of a square minus x square as we see here, because 9 can be written as 3 square and x square is already x square. So under root a square minus x square dx will be equal to x by 2 under root of a square minus x square and a square by 2 and sine inverse x by a. We have no assumption, no substitution, directly x as x and a as 3 as given in the question. Now I am putting this all in equation number 1. X to be replaced by x and a to be replaced by 3. So x by 2 under root same thing 9 minus x square plus a square by 2 which is 3 square which is 9 by 2. So 9 by 2 we have sine inverse x by a, that is x divided by 3 plus a constant of integration. This is your final result. Okay, this can be very clear when you usually do it by yourself. Under root 16x square plus 25. Now there is a new concept which I am going to highlight here. If you take this 16x as 4x whole square, it will be 16x square. 25 can be written as 5 square. Now x square plus a square formula is known to us. But the problem comes here is what to do with this 4 which is preceding x or which is along with x as a coefficient. So we need to get rid of this. Otherwise people will say take 4x as x and 5 as a. But that's not the case. So in order to get rid of this 16, I'll take 16 common. And when you take anything common, it is just that division divided by everything which is inside. So 16 if we take common, x square by 25 by 16 will come. So 25 by 16 can be written as 5 by 4 whole square. 5 5 are 25, 4 4s are 16. So now we can change this equation or modify this equation according to us in this way, that this under root 16 which has come, actually it's under root a into b form. So under root a, I am taking under root a as under root 16, under root b as under root x square plus 5 by 4 whole square. You can always take this outside. Under root 16 or root of 16 is 4. So this 4 will come outside even if you take the integration. So we'll talk about this 4 in a bit. We'll deal with this x square plus 5 by 4 whole square, which is actually the formula x square plus a square. So let me revise you or made you recall this equation which is x by 2 and in under root a square x square plus a square. Remember, this is not under root x square plus a square, it is the integration of under root x square plus a square, right? This is the integration of under root a square plus x square plus a square or a square plus x square, whichever way you call it. So x is equal to x we are going to take and a will be taken as 5 by 4. I am putting this in the formula of integration of under root x square plus a square dx. X by 2 under root x square plus a square, let's write it just like that. X square a is 5 by 4 whole square for us. Plus a square by 2, what is a? And a square 5 by 4 whole square divided by 2. So 25 by 16 and there is a 2 also. So we need to multiply the 16 by 2 in the denominator. So we get 25 by 32. 32 ln modulus x plus under root x square plus a square. A will be 5 by 4 whole square in this case plus a constant of integration. Now 4 was already there. So let's multiply this 4 with each term. 4 into x by 2 will give you 2x. Under root x square plus 5 by 4 whole square, you can write it as 25 by 16. 25 by 32 will also be multiplied by 4. So 8 4s are 32. It will be 25 by 8. ln modulus of x plus x square plus 25 by 16 again plus a constant of integration. This is your answer. And this has come from integration, okay? I am talking always about integration of this particular term. Let me write it also. It's under root 16x square plus 25 integration of dx with respect to dx. So this is the reference for you. You can use it. Under root 4x square minus 5. Now we need to get rid of this 4 in order to apply the formula directly. So we'll take 4 common from here, and taking common means dividing that term with whatever is inside. So x square minus 5 by 4 will come. Now assume this to be under root a b. So under root a into under root b we can write. So we can take this under root 4 outside or as a separate term, and what remains is under root x square minus 5 by 4. Under root 4 is directly 2, or square root of 4 is 2, so we will use it just now. We are going to deal with under root x square minus 5 by 4. 5 by 4 can be made as a perfect square. So 2 integration of x square minus 5 by 4 can be written as root 5 by 2 whole square, which will give you 5 by 4 ultimately. But we need to make it look alike the formula so that we can apply the formula. So root 5 by 2 whole square is a square actually. Now let me write the formula here somewhat below so that you can see when I apply it. It's x by 2 under root x square minus a square minus a square by 2 ln log base e x plus under root x square minus a square plus a constant of integration. This 2 we are going to deal just now. In place of x, put x. In place of a, write root 5 by 2 in this formula which I showed you just down below. X by 2 under root x square minus, what is a? Root 5 by 2 whole square, which is 5 by 4 only. Then minus a square by 2. What is a square? Root 5 by 2 whole square will again give you 5 by 4 only. And there is a 2 also. So we have 5 by 8 and ln log base e x plus under root x square minus 5 by 4 plus a constant of integration. We have already arrived at the answer, but there is just a bit. I told you 2 I am going to introduce just now. 2 into x by 2 will be x only. Under root x square minus 5 by 4, 2 will be multiplied by 5 by 8 also. So 2 4s are 8. It will give you 5 by 4. ln modulus of x plus under root x square minus 5 by 4 and then a constant of integration. So this is ultimately integration of 4x square minus 5 under root with respect to dx. Alright, so let me show you the reference also. It's important for 2x square plus 3x plus 4. So this is inside a root. So we don't need anything in front of x square because we want to make it as a perfect square. If you take 2 outside, whenever we take something outside, it is just dividing every other element inside. So we have x square plus 3 by 2x and plus 2. And this all is inside. Now we'll make the perfect square. So this 3 by 2, take this 3 by 2, divide it by 2. So when you divide it by 2, it will be 3 by 4. Now you square it, add it, subtract it. So 9 by 16 will come, and you can just add 3 by 4 whole square and subtract 3 by 4 whole square as well in order to make it as a perfect square. Okay, adding, subtracting and plus 2. And this is a square plus b square plus 2ab. So this is simply x plus 3 by 4 whole square. And now remaining is 2 minus 3 by 4 whole square. So 2 minus 9 by 16 it is. It will be 16 to the 32, 32 minus 9 divided by 16. So this is going to be 23. So 23 by 16 will come. And in order to make it as a perfect square, you can write it as under root 23 because 23 under root whole square is 23 only. But 16 is a perfect square, so it gives you 4 square. That is why we can write it here plus under root 23 by 4 whole square. This is under root. Now under root a into b is what? Under root a into under root b. So you already have a under root 2 because 2 was inside. I took it outside. So you can just take this under root 2 outside and apply the formula of x square plus a square. Now under root x square plus a square is already being defined to you. So it is x by 2 under root x square plus a square. Then we have plus. This is not minus. I'll just change it. A square by 2 log base e, that is ln x plus under root x square plus a square plus a constant of integration. So let me make it as positive because under root x square plus a square is everywhere positive on the right hand side when you integrate it with respect to dx. So in place of x, we'll take x plus 3 by 4. In place of a, we'll take root 23 by 4. Root 2 will just deal later. So this is x plus 3 by 4 divided by 2 under root x square plus a square, so x plus 3 by 4 whole square, and plus root 23 by 4 whole square. I'm just keeping it like this because when you multiply it by under root 2, it will come as the same thing from where we started. Now a square by 2, root 23 by 4, 16 actually. So 16 into 2 is 32. 2 was already there in the denominator. Ln modulus x plus 3 by 4 whole square. X plus 3 by 4, then x plus 3 by 4 whole square plus root 23 by 4 whole square. So now you can write x square plus 3 by 2 x plus 2 because this is after taking under root 2 outside. So whatever is inside under root x square plus a square, because root 2 will be multiplied only to the outside thing, not inside the ln, not inside the log. So now multiply root 2 with both the terms. X plus 3 by 4 will form 4x plus 3 by 4, and it is 2 already. So you can write it as 8, 4 to the 8. So we have this as 4x plus 3 divided by 8, and root 2 you multiply inside the root. So when it goes inside under root 2 into x square plus 3 by 2x plus 2, this will give you the original equation which we wanted to integrate. It will be under root 2x square plus 3x plus 4. Now 23 by 32 root 2, you don't have to multiply, just write it like that only. 23 by 32 under root. And this is log base e ln x plus 3 by 4. And this is, this will remain same. There will be no change here. So x plus 3 by 4 plus, there is a plus also in between, under root x square plus 3 by 2x plus 2. This is your final result plus a constant of integration also. So this is the final integration. So this is your reference which you can adopt while solving it by yourself. And this formula is very important. Now this question I will leave it for you because we have already done 10 questions. But I'll tell you the basic step. You just have to make it as a perfect square and apply the formula. So when you take negative outside, you will get 2x square plus 2x minus 3. Now just take negative 2 actually. Negative will not solve our purpose. We have to take negative 2 outside. So when you take negative 2 outside, that simply means you are dividing every element inside remaining by negative 2. So dividing by negative 2 will give you the result like this. It will be x square plus x minus 3 by 2. Now here this is a quadratic equation. So what is the coefficient of x? It is 1. Divided by 2, it will be 1 by 2. Square it, add it, subtract it. So x square plus x, half square I am adding, half square I am subtracting with a negative 3 by 2. Minus 2 is outside only. So this will give you x plus half whole square. A square plus b square plus 2ab, x plus half whole square. And this will give you 1 by 4 plus 3 by 2 actually. So it will be 12 plus 2 by 8, it will give you 14 by 8, 7 by 4, and it is negative under root 7 by 2 whole square. 7 by 4 can be written as under root 7 by 2 whole square. Now there is an issue with this negative because you cannot have a negative inside a root. So we'll take this root 7 by 2 first and then afterward x plus half whole square, because now we have multiplied by negative. This root 2 can be taken outside. Here you can apply under root a square minus x square formula. So this question you already know because this type of question we have already done. You can follow these instructions. So this question, we know that x square can give us x. The differentiation of x square can give you x. I am suggesting x square equals to t. Just assume it to be t. When you differentiate both the sides, it's going to be 2x equals to dt by dx. Now you can just find x dx and keep everything on other side. So x dx can be now placed as dt by 2. So I'm placing this dt by 2, half is outside now. X to the power 4, x raised 4 means what? X square is t, so x raised 4 is t square. So t square plus 1 square. Now just apply x square plus a square formula with an under root. So I'm directly applying the formula. X you have to take it as t and a as a 1. So it will be x by 2, half is already there outside, t by 2, under root t square plus 1 plus a square by 2. What is a? It's just 1. 1 square will be 1 only, 1 by 2 I am writing. And ln, that is log base e, t plus under root t square plus 1 plus constant of integration. Now wherever t you get, just replace it by or substitute it by x square. So x square by 2 here, multiply it with outside 2, it will be 4. So x raised 4 plus 1 because t square is x to the power 4. Again multiply it by half outside, so half into half will be 1 by 4. This will be log x square, and again same thing, x raised 4 plus 1 plus a constant of integration. So this is your integration of x under root x raised 4 plus 1. So this is the reference. You need to understand and learn the formula so that you can solve it easily. And if you are aware of the differentiation, this question will be very easy. Under root x square plus a square formula is very important to remember. Now x square dx you want. This is outside. So when you take t equals to x cube and differentiate this, dt by dx will be equal to what? 3x square. So dt by 3 can be written as x square dx. So this x square dx is already given in the question, this x square and dx. We will try to put dt by 3 in for it. So dt by 3, 1 by 3 will go outside. I'll just write it. Inside will be a cube whole square minus x cube. We have already taken t, so it will be t square. X to the power 3 to the power 2 is x raised 6 only. So it will be t square. Now a square minus x square under root formula we are going to apply. And you are aware of the formula. We have already learned it. So this is 1 by 3 also. Let me add it. We'll just deal this 1 by 3 later. Now this will be t by 2 under root a square minus x square. What is a here? A is a cube. So x you are taking as t, a you are taking it as x cube. A cube whole square minus t square. And then plus a square by 2. What is a? A cube. So a cube whole square by 2. And then sine inverse x by a. That is t by a cube. Now wherever you get t, just replace it by x cube. So x cube by 2, but there is a 3 also outside. So multiplied by 3 denominator, 3 to the 6 will come. So x cube by 6 under root a raised 6 minus t square. What is t square? Again x raised 6 plus a raised 6 divided by 2. 3 to the 6, so it will be 6 because 1 by 3 is already outside. Sine inverse in place of t x cube divided by a cube plus constant of integration. This is your integration result. Now how we are going to do? This is the reference for you. You can do it by yourself also. This is a good question actually. 16 plus log x whole square divided by x. Now we know differentiation of log x is 1 by x. So if we take this some t as log x and differentiate this, dt by dx will be what? 1 by x. Dx will go up, so dt will be equal to dx by x. So this dx by x will be dt. So integration of 16 is 4 square you can write. Under root log x we have taken as t, so 4 square plus t square inside a root. And then a dt also. A square plus x square formula can be directly applied here. A square plus x square, and this is the integration what we are doing. A will take it as 4, x as t. So this is going to be x by 2, so t by 2 under root a square plus x square, that is 4 4 so 16, 16 plus t square plus a square by 2, 16 by 2, it will come as 8 ln log base e modulus of t plus under root again 16 plus t square plus a constant of integration. So wherever you get t, just replace it by log x. So in place of t use log x. So log x divided by 2 under root 16 plus t square is what? Log x whole square plus 8 log base e ln. So log x plus under root again 16 plus log x whole square. T square is log x whole square. And then we have a constant of integration. This is your integration result. And this is how you are going to go about it. If you understand log x differentiation is 1 by x, this question will be quite easy for you, along with the under root a square plus x square formula or x square plus a square under root integration formula. Now this question has no constant here, that is a is given. And this kind of question we have already done because this is already a quadratic equation. 2ax minus x square. First we need to get rid of the negative in front of x square. So I am taking negative outside, x square minus 2ax is there. It will remain inside. Now what is in front of x? It is 2a coefficient. Divided by 2, a will come. Square it. Now add it and subtract it. So I am adding a square and subtracting a square. So a square plus b square minus 2ab. This will be simply x minus a whole square. If you open it, x square plus a square minus 2x will come. Minus a square is also there. But negative we cannot have inside a root because actually we are dealing with under root 2ax minus x square only. So when you take in negative inside, these terms will get swapped with the sign. So a square minus x minus a whole square, and this is inside a root. And we are doing integration here with respect to dx. A square minus x square formula we are using. X will take it as x minus a and a as a only. So this will be, that is x by 2, x minus a by 2 under root So a square minus x square, this has come from original only, 2ax minus x square only. If you open it, it will come as 2ax minus x square only. So let me write 2ax minus x square plus a square by 2 sin inverse x by a, which is x minus a in this case. So x minus a is a only, plus a constant of integration. So this is your final result. So this is how you are going to go about it. This is a different way I have done it or showed it. Now this is a direct formula actually. So under root 3 minus x square, you can write under root 3 whole square for 3 minus x square. So integration of under root a square minus x square you have to perform. So this formula you are already aware. So a will take it as root 3 and x as x. So I'm just directly using the formula now. X by 2 under root a square minus x square is original equation only. You can just write 3 minus x square here. And plus a square by 2. What is a square by 2? It's root 3 whole square by 2. You can just write 3 by 2. And then sin inverse x by a. X is x only. A is root 3 plus constant of integration. So this is the direct result of under root a square minus x square, where a is under root 3. X square minus 2x. So you have seen 2ax minus x square just now. The same way it has to be done. Only a is 1 here. So x square minus 2x, because this is a quadratic equation, you have a coefficient 2 in front of x, divided by 2, 1 will come, square it, add it, subtract it. So I have added 1 and subtracted 1. So x minus 1 whole square will come, a square plus b square minus 2ab, x square plus 1 minus 2x is x minus 1 whole square. And 1 square will also be there. So x square minus a square formula we are going to apply here. X will take it as x minus 1 and a will take it as 1. So what will be the formula of integration of under root x square minus a square? It will be x minus 1 by 2 and then under root x square minus a square, which is the original equation only. So you can just write x square minus 2x here directly, because this all changes we have done to the original equation only. Then we have minus a square by 2. What is a? 1 by 2. Now ln modulus of x minus 1 plus under root again, same thing, x square minus a square. So x square minus 2x will again come. So you can write under root x square minus 2x plus constant of integration. This is your final result. And this is your reference. This is a good question. Now this 2x minus x square. Now again there are 2-3 questions we have done like this. But I will give you 2 options. One more option I will show you. So the one option is 2x minus x square. You can take it as like this, because taking negative outside will form x square minus 2x. Now just divide the coefficient of x as divided by 2. 1 will come, add it and subtract it. This will be x minus 1 whole square minus 1 square you can write. Negative is outside, so you cannot have a negative inside a root. So just swap this term with multiplication of negative. So 1 square minus x minus 1 whole square will come inside a root. You just have to integrate this. A square minus x square formula you already know. So under root a square minus x square dx you have to apply here. Alright. In place of a, take 1. In place of x, take x minus 1. And there is another way also. You can just take x common from here. This is the first way you can just do it in this exercise, because this exercise is all about the formulas. This 2x minus x square, you can just take x common. X minus 2 will come inside. So you just take this as u and this as v. X as u and x minus 2 as v, or otherwise. So integration of u dot v you can apply, whichever is easier for you. But I think that this x, integration of x or x minus 2, it will increase. It will get increased, and in incremental way you will find stuck somewhere. So it's better to adopt the first option. And there is one more option which I can show you. It's quite tedious, but there are people who can think like that. So everyone has different IQ. So those who have high IQ, they can just do it like this. But it's not required here. The first solution which I told you is the enough. This is all about this. Thank you.